In this video, Mass Flow Online, a business unit of Bronkhorst High-Tech, the market leader in the field of thermal mass flow meters and controllers, presents the operation of the MassView series thermal mass flow meters, regulators and controllers, employing the direct through-flow measurement technique. This thermal mass flow instrument is supplied with 15 to 24 volt DC. After power-up for the first time, the multifunctional OLED display shows a setup. This menu allows you to select main settings for your process. Press in the center of the four-way button and navigate to the fluid name using the up and down direction. Press in the center once again to make a selection. Subsequently, the flow capacity and communication type are selectable in the same way. These settings will be stored when the Save button is pressed twice. Now the instrument is ready for use. Under the cover of the MassView is the electronics board using surface mount device technology. The measuring part of the instrument consists of a flow straightener element combined with the thermal inline mass flow sensor. The flow sensor consists of two stainless steel pins encasing the heater in the first probe and the temperature sensor in the second probe. A constant temperature difference, or delta T, is created between the two sensor probes. Once the instrument has been connected to the process line and the pre-pressure has been set, the measured value corresponds with zero flow as long as the manually controlled needle valve is in a closed position. The needle valve, which has an orifice with a long tapered conical seat, makes it possible to regulate the flow rate. A needle-shaped plunger on the end of a screw exactly fits the seat. As the screw is turned and the plunger retracted, flow between the seat and the plunger increases. Since it takes many turns of the fine-threaded screw to retract the plunger, precise regulation of the flow rate is possible. Now the gas passes through the flow straightener, thereby creating the laminar flow profile that assists with stabilizing the measurement conditions. The flowing gas cools the heater probe, and the comparator registers that the temperature difference between the two probes decreased. More energy is applied to the heater probe to maintain the desired constant temperature difference. This increase in heater energy is directly proportional to the mass flow as originally set out in King's law. The higher the flow, the more heater energy is needed. The bright graphical OLED display, clearly visible over any angle, allows reading of actual flow, value and bar graph, total flow and fluid type. If there are any alarms activated, their values will be displayed at the left side of the graph. Mass Flow Online and Bronkhorst would be delighted to share their experience and knowledge to work together with you to improve your process. Bronkhorst, performance for life.